Alright, we are back again with another wacky physics video. I'm Ryan, and let's get right into the physics. So, today we have this problem right here, and it starts off with a 4-meter long string that is tied to a 0.05 meter radius cylinder and rotated at a constant angular velocity of 0.5 radians per second. How much time does it take to wind the whole 4-meter string around the cylinder? So I provided an illustration below to kind of help you visualize the problem. And we have this string right here, 4 meters long in this cylinder. Now, the way I drew it is I drew the string wrapping around the cylinder, but the cylinder could have been spinning as well. Either one would have worked, I think. But the end result would look like this, where the string wraps around and the cylinder completely wrapped with this 4-meter string. Now, what do we know? We know a length, 4 meters. We know a radius, 0.05 meters. And we know an angular velocity, 0.5 radians per second. And we're trying to solve for how much time it takes to wind the whole 4-meter string around the cylinder, or the delta time. Now, equations to consider. I didn't have too many equations that you should consider, but I put down 2 pi r, which is how you find the circumference of a circle. That would help a lot. But with that in mind, we should be able to start the problem. Alright, so the first thing we need to find is we need to find how many rotations it takes for that string to be fully wrapped around that very small cylinder. And to do that, we need to find the circumference. Now, to find the circumference is 2 pi r, right? You plug in the radius 0.05 in for that equation, and you should get 0.314. Now, with that, that's the circumference, so that's how much length it takes to wrap fully around the circle once. Now we need to find the amount of rotations in that 4 meters long string. And the way we do that is by taking the length of the string and dividing it by the circumference. Because if we divide the length by the circumference, we should get how many loops we can get with said length. So 4 meters divided by the circumference we got, which is equal to 12.7 rotations roughly. Once we get that, we need to change our angular velocity of 0.5 rads per second into revolutions per second. Now the way we do that is by dividing this rads per second by 2 pi, which gives us 0.07 revolutions per second. Now that we have this revolutions per second and we have these rotations and revolutions are used synonymously here, we can find our change in time. We defined our change in time by dividing our speed, which is 0.07, into our amount of rotations we have. So we have 12.7 divided by 0.07. We should get 160 seconds, roughly. And that makes sense, because if we look at the illustration above, this is actually a very not to scale illustration, but this cylinder should be very, much smaller than this. If we have a 4-meter long stick, it would be like a 15th, maybe even smaller than that. And it makes sense that it would take a really long time for it to wrap around, because the thing is so darn small that and the speed at which it's going to take a very long time for it to wrap around. But yeah, hopefully that's helped you understand how to handle these sorts of problems. If it did, please be sure to like, favorite, and subscribe, and I will see you in the next wacky physics video. Thank you.